Okay, so we're in Algebra Chapter 5, Section 7, the last section for this chapter, and we are going to predict with linear models. So we've spent a lot of time writing equations in this chapter and reinforcing what we know about slope and about y-intercepts. And so now we can use equations to predict things. So this takes us to yesterday where we were talking about the best fitting line, right? So the best fitting line is what? How would you describe what the best fitting line is? Tara?
Average and volumes.
Good, okay. And so we use it with what types of data when we plotted what kind of a plot, Lauren?
A scatter plot.
Good. So we look for the trend, the correlation was the word we used yesterday, right? And so the best fitting line of fit is the line that most closely follows the trend in the data. There you go. Okay, there is another word for using a best fitting line to forecast things, and it is the lines that we have, or the correlations we have found in this chapter have to do with lines. So this is called linear regression. Using a line, a best fitting line to make a statement about the data. So as we just saw with our assignment, when you fit a line in the data, we kind of throw out the data that we received, and we now just use the line to give us information, right? There are two kinds of points that we can pull out of the information given. The first is called linear interpolation. Okay, the other one is called linear extrapolation. So we have inter and extra. So the question is, what's the difference between these words inter and extra? Can you think of another word that has inter as a suffix? Interview, intercept. How about like an intersection, right? Interview. So the points that we find using interpolation are points that are inside. So you can see the word in here, inside of the data set that we have. So when you use a line to approximate values between two of the known data values that we plotted, you're using interpolation. Okay? But we know that when we draw a line in our data, the line by definition goes on how long? How long is a line by definition? Never ending, Lauren says. So it is infinite. So if we put arrows on the ends of our lines, right, we can go beyond the set of data. So when we go and use the line that we have placed, the best fitting line in the data, when we go outside of the set of data that was given, we're using linear extrapolation, okay, outside the known range. So when you think about it, extra, like outside. Exit takes you out. Inter is inside the data. Okay, so it's using our best fitting line to draw conclusions, either inside of the range that was given by the scatter plot or outside of the range. Okay, you're not going to draw this, but as an example, this is a piece of data that is on page 327 in your book, and it's talking about over the number of years how many clusters of birds are found. So the table shows the number of active red-cockaded woodpecker clusters are in a part of a forest in Mississippi. So look at, over the years, what's happening? They've taken some samples of the population of this type of bird, right? And they've plotted these points. So over the years, like since 1990, so in this year 2, what year would it be? Maddie? If this is years since 1990, what would this year 2 be? In 1992, it looks like they took a sampling and found, there are about 21 or 22 clusters of this type of bird. But look at what happens in the year 10. Year 10 would represent what year in the calendar, everyone? The year 2000. It looks like there are a little over 50 clusters of these birds. Okay? So, and then they have a whole sampling in between over the years. So they've put a best fitting line. So if we were using linear interpolation, we throw out the actual points found, and we use our line to make an estimate, right? So we could say that in approximately 1990, in 1999, how many clusters of birds would you estimate?
45.
So Kelly says 45, good. And so, and that point looks like it's almost in that spot, doesn't it? But they've given us so much data here that it's hard to even not use the data itself when we're making these estimates, but that would be interpolation, using a point between the data. Look at the year 1995. How many clusters of birds could we estimate using our best fitting line for 1995? We would say 32. Throw out this piece of data. We're using linear interpolation, so we use the line. Now, maybe this piece of data said 27, right? But we may have, the scientists may have missed some clusters, right? So we're going with the data here, or the line, not the actual scatter plot. So our estimation is in the year 1995, there were about 32 clusters of these birds. That's using interpolation. If we were going to use extrapolation, tell me, what do you think is the number of clusters of this type of bird in the year 2001? So we're looking up here, aren't we? So 50, each blue line represents 5 in the vertical direction, so 54 maybe, 53, okay? And we could go beyond, right? We could extend that line, and that would be using extrapolation, taking and using the line to estimate what's going on after the data that we have, okay? So thumbs up if you understand extrapolation, interpolation, good. Okay, so now let's talk about something a little more tangible, a little more mathematical, and that is the zero of a function. So we see a equation here written in what kind of notation,
F of
Kelly?
X.
What do you call that? F of X?
It's basically y.
It is y, but what do we call this type of writing? It is what? Function notation, good. So Kelly says that basically you could replace the f of x with y. It's a way to name a function, right? If we say that y equals 0, when y equals 0, and we discover the x coordinate, what kind of point do we have? Imagine a coordinate plane. When y equals 0, you are not flying anywhere, and you have very good, you have an x-intercept at that point, okay? So when we find the zero of a function, we are locating the x-intercept. So when you're asked to find the zero of a function, just substitute 0 for y and find x. So this is a really important topic, finding the zero of a function. There's a really common error made when asked to find the zero of a function, and we've talked about this before. Where do you think a person might plug 0 in when asked to find the zero of a function?
Plug it in for x.
For x, right? The common error is for somebody to plug in a 0 for x, and you end up with negative 20 here. And that would be a y-intercept, right? But as Maddie just said, we're not looking for a y-intercept, we're looking for
X-intercept.
good. Okay, so how would you write this equation in order to find the zero of the function? How would you write it, Selena? Very good. So she says plug the 0 in for where the y would be, or f of x, right? Good. And now we have a simple equation to solve. So it's not the solving of this equation that's hard for any of you. You're strong with that. It's going to be, can you understand the question when it's asked? Find the zero of the function. Okay, it's kind of like a horizontal vertical lines. Once you practice one and you have it down, during this assignment it'll be a breeze, but when this is sprinkled into a test with a lot of other types of questions, will you remember to plug a zero in when you're finding the zero of the function? The zero of the function means the value of the entire function is zero. So we do exactly this, and we simply finish, right? And we say 20 equals 7.5x. So when we divide, what do we have for x? 7.5 times 2 is what? Is 15. So it's going to go in twice, and then you could say what? I mean, if you want, you could say this. It goes in twice, and then what's left? 5 out of 7.5. Now, we don't typically keep fractions in a fraction, right? This is a decimal and a fraction. So we could blow this up. We could multiply top and bottom by 10. And what is 50 over 75? What? How many? 2/3. What is it? 2/3. So we end up with 2 and 2/3 equals x, because you can reduce 50 over 75. Okay? So when x is 2 and 2/3, that was when y was 0. There is the zero of the function. Okay, so it's not a long assignment. It's just really important that you get it in your head how to find the zero of a function. And then, of course, the other topic was using your best fitting line to estimate data within interpolation or outside extrapolation of a function.